first problem, it says to simplify, and so you have to show your work. Thanks for putting your phone away, Sachi. And so you want to break this down. Now, some of you guys, if you understood how to do this the way I showed you, where you're looking for a number from that list that divides into 600, the beauty of that is it's faster. However, like a number as big as 600, I don't want to start dividing that by 2 over and over and over again. I mean, hopefully you can remember that 100 is a perfect square and 600 is divisible by 100. And so that's really just the simplest way to do this one. So that would be radical 100 times radical 6. The square root of 100 is 10 times the square root of 6. That's all there is to that. All right? Yes?
Everybody getting into one?
I don't know. I didn't judge it. No, because somebody, at least one person made 100. There was some 97, 93. I mean, that's just one. We had this problem a lot, where you had to rationalize the denominator. We did that in the very first part of the unit, where we practiced doing this. So this becomes radical 18 over 6. And radical 18 breaks down into radical 9 times radical 2 over 6. That becomes 3 times radical 2 over 6. And 3 reduces into 3 divides into 6 twice. So that becomes radical 2 over 2. Okay? All right. So there are a couple things you had to know. You had to recognize that you had to rationalize the denominator. And then you needed to know how to simplify that radical and how to simplify a fraction. Right. Okay. Any questions about that? Radical 6 times radical 6 is radical 36. The square root of 36 is 6. So we have a shortcut that we take there. Okay? Laura, you need to be writing this down. I'm not saying. Wait. Okay. Number 2. So once again, when you have two radicals, you multiply. Okay, and then you had to break this down. Okay, so 45. You want to use a square number, so you need to pick a number from that list. So even if you just pick any number that's on our list of square numbers, do you know what I'm talking about when I say our list of square numbers? Your 1, 4, 9, 16. So if you just take the calculator, if you don't have to memorize the list. It's just 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. That's how you make the list. And then you just see, do one of these numbers go into that? And then if you do it that way, just keep breaking it down as long as you can. Okay? So the square root of 9, that's a perfect square. So that's going to be 3 times the square root of 5. Does 5 break down? No. 5 doesn't have a perfect square factor. So we're done.
That's the kind of work you want.
That's the work I need to see. I need to see however you break it down, I need to see it. Like some people may have done it like this. They may have said, okay, well 45 is divisible by 3, but if you use 3 and 15, it doesn't help you. Because if you break this down as 3 and 15, neither of those are square numbers, so I can't do anything with that. That doesn't get me anywhere. So you have to use a number that's a square number. It has to be from our list, okay? I'll look at it. If I didn't, I'll look at it again for you. Look at it, okay? In fact, I'll just look at one. All right. So for this one, we multiply numbers with numbers and radicals with radicals. So it's 2 times 3 times radical 125 times radical 5, which gives you 6 times the square root of 625. And so you may not recognize it, but 625 is a perfect square. And you have the calculator, so you can always test numbers to see if they're perfect squares. And, pardon me? It is exactly 25. So the square root of 625 is 25. It's 25, which gives you 150. Now, if you had taken a different approach, you could have broken. I'm just going to do this as a different way. you could have broken 625 down. You would have said, well, maybe that's divisible by 25. It is divisible by 25. It goes in 25 times. So you could have broken, in fact, I remember seeing someone broke it down this way. That's cool. Because then the square root of 25 is 5, and the square root of 25 here is 5. You still get to the answer. So that's a different way to get to the answer. Alright, as long as you're using a number that's a square number as one of the factors that you're splitting it up into, okay? So even if you don't start off with the smallest square number, as long as it's a square number, and then you just keep breaking it down as long as you can. Okay. And so this problem, we had to find the perimeter. Perimeter is the distance around the figure. So we were missing this length right here. If we know two sides of a right triangle, how do we find the third side? Pythagorean theorem. So this was a hypotenuse, this was a leg. So we have a squared plus 8.6 squared equals 12.5 squared. And so, well, I kind of did the rest of mine in a calculator. So once you, what's 8, does anyone have 8.6 squared? Say it again. I'm sorry, somebody start talking. 73.96, thank you. And what was this one? And then we would subtract this from both sides.
I said 100.
Oh, I'm sorry, thank you. 156.25.
Yeah.
And so we're going to subtract 73.96 from both sides. And we get a squared equals 82.29. And then you have to, some people forgot to take the square root of both sides here. And when you do that, that's how you get the 9.1. So you do have to take the square root of both sides to get 9.1, which goes here. So this is 9.1. And then to get the perimeter, you're going to do 9.1 plus 8.6 plus 12.5, and you get 30.2. Okay. So you have to use the Pythagorean theorem. So if you're taking notes, if you got this wrong, then you need to write a note to yourself. Use the Pythagorean theorem to find the missing side, then add all the sides together. Just writing the work down isn't enough if you're not adding some little hints and notes for yourself, okay? Excuse me, second. Without what? No, you can use a calculator. You have to use a calculator for that. Okay? Okay. Number 6. So for number 6, the correct answer was B. I mean, it was kind of, you had to do the process of elimination. So it says, which one does not form a right triangle? And so you're testing to see if 2 squared plus radical 7 squared, does that equal the square root of 13 squared? And so this gives you 4 plus 7, which is not equal to 13, because this is 11. So that's why that does not form a right triangle, because it does not work in the Pythagorean theorem. Okay. Any questions? Ma'am? What about the perimeter? You add all the sides up. Okay. Elijah, put your phone away, please. Now this one was a struggle for some people. Tell me, I wish you guys would tell me what made it a little more confusing, because you guys have done problems like this. So I was really kind of surprised, because you know that the 3 angles of a triangle make 180. Now, you could have taken 2 different approaches. You could have included the 90-degree angle and said 90 plus x plus 28. Because this represents an angle, that represents an angle, and then x plus 72. You didn't have to put the parentheses. I'm just doing that so you can see that you have 1, 2, 3 angles that add up to equal 180. And you guys all know that fact, so I don't know, maybe it was just how the problem looked, I'm not sure. But we had one like this in our review. So anyway, when you combine all your like terms, I got 2x plus, I'm sorry, I did mine differently. So the way I did mine was I added these two up and set it equal to 90. Did anybody do it like that? Okay. So you could have just taken these two angles right here. Since we know this is 90, these two also have to add up to 90. So anyway, I think is this 200? When you add these together? No, that's 100? 28 plus 72 plus 90.
Plus 90? Oh, you did one.
Yeah, I did it. Well, I set it up like this, so I'm just going to continue like this.
I don't know.
This is 190
190.
equals 180. Yeah, those are angles that are inside. They're inside. And the question said find the measure of the angle. So then we're going to subtract 190 from both sides. And we get 2x equals negative 10. And then divide both sides by 2. Okay. All right. Let's keep going. Next page. Okay, sorry. All right. Sure. Now, I think you will find that I probably gave more credit in some cases than other teachers did because I was listening to how they were grading their tests. And, okay. So, where are we right here? And how do we find what? Oh, so once you find the measure, thank you, we actually didn't finish the problem. So then to find the actual measure of the angle, we have to do negative 5 plus 28 because x is negative 5. So now that we know that what x is, that will give us 28 degrees. Okay, my apologies. Okay, good. Okay, any questions about that? Okay, make sure you're processing, make sure it makes sense, and make sure you're writing down information to help you, okay? Yes. Say it again. 90 plus 28 plus 72. Okay, so this angle right here is 90. Okay, because the three angles of a triangle add up to 180. Alright. So, you good, Cam? You got that? Alright, so you're just combining like terms, x's with x's and numbers with numbers. Okay? Alright. Can I go on? Alright. Okay. What was that? Sound like a phone. Alright, so let's take a look at this one. So, these were your special right triangles. So we have 30, 60, 90. So we had to memorize our formulas. That was x square root of 3, and 2x. And so the side opposite the 30-degree angle was 3 radical 7, so that goes here. Alright, so that means, this means x equals 3 radical 7. So for the rest of the problem, every place that you see an x, you replace it with 3 radical 7. So this becomes kind of tight, but this is 3 radical 7 times radical 3. You still have that square root of 3 there. So they have to get multiplied together. That gives you 3 times square root of 21. Alright? So that's this leg right here. Right? And then for this one, it's 2 times whatever x is. X is 3 radical 7. So it's 2 times 3 radical 7. Okay? It's 2 times whatever x is, which gives you 6 square roots of 7. So this is 3 square roots of 21. And this is 6 square roots of 7. Okay, ask me questions about that. special right triangles, they're hard for students, yes, I get that. Yes, sir. Yes. Okay. All right, number 9. So this is a 45, 45, 90 triangle. So our formulas for that, that's just x, and x squared root of 2. Mm-hmm. Somebody have a question for me? All right. So what do we know? Where does the 6 go?
Oh, yeah, 90.
Yeah, with the 90, because it's opposite the right angle. So it goes here. So that means this equals this. See, whatever is here is equal to whatever's down here. So sometimes you have to solve an equation to get it. So then that cancels out. We end up with x equals 6 over the square root of 2. But of course, we're not allowed to leave the square root of 2 in the denominator, right? We have to rationalize the denominator. And that gives me 6 square roots of 2 over what? 2 over 2, and then 2 divides into 6 roots of 2. So both of these are 3 square roots of 2. All right, any questions about that? Yes. Yes. Sure. You want me to back up? First statement, how did I get there? So, remember. Okay, how do I work from that point? How do I solve that? Okay, so so just remember, if I gave you x times 2 equals 6, we would divide both sides by 2, wouldn't we? All right, to get the x by itself. You agree? Okay, so that's what we did. We divided both sides by the square root of 2 instead of 2. It's the square root of 2 because I'm trying to get my x by itself. So I did. So the square roots of 2 cancel out. The x is by itself. But on the right-hand side, I end up with 6 over the square root of 2, which I'm not allowed to read in that form. So I had to multiply the bottom by the square root of 2, and whatever I do on the bottom, I do on the top. And so then 6 times the square root of 2 is just 6 times the square root of 2. But the square root of 2 times the square root of 2 is the square root of 4, which equals 2. So that's where this 2 came from. And then I divided 2 into 6 and got 3. Okay? Anybody else? This 6 right here? This 6 came from the picture. It's okay. Alright. So this was another, I would say that these 3 questions, those 2 and this one would probably be the type of question that would separate an A from a B, okay, or B from a C. So if you could do everything else. So for number 10, this one was hard. We have equilateral triangle. That means all the sides are the same. But we don't know how long the sides are, but they did tell us what the height was. The height is 6. Now, if you have an equilateral triangle, all the angles are the same. So that means that this is 60 degrees. So I could kind of pull that out and just deal with that triangle right there. And so if I know how long this hypotenuse is, then I know how long all 3 of these sides are, because they're all the same. So you just had to do a trig function. It didn't say you had to do it as a special right triangle. You could have. Alright, I did mine just as a sine. So sine of 60 equals opposite of the hypotenuse. X is on the bottom, so you're going to divide. X equals 6 divided by sine of 60 degrees. That ended up being 7, yeah. 9, 7, something like that. If you did it as a radical, I think you would have gotten 2 square roots of, I don't know if I did it as a radical or not. Alright, any questions about that? Here, you could do it like that? Instead of as a special right triangle? It didn't say you had to. So all special right triangles can be done as trig functions, but if the question says leave your answer, like if you look at number 8 and 9, it says leave your answers as simplified radicals. You have to do it, you have to leave it that way. I guess technically for number 9, technically it was expecting you to do it as a special right triangle based on the directions, but I gave credit for it either way. So if you did it as a special right triangle, did you get 2 square roots of 3?
Yeah.
Yeah. So if you did it as a special right triangle, you would have gotten 2 square roots of 3. So that was nice. I went ahead and took credit for it either way. Okay. Because if it's equilateral, that means all the angles are also the same. Does that make sense? Equilateral triangle. So if they're 180 degrees, 180 divided by 3 is 60, okay? All right. Okay, guys, let's stay focused. Number 11. So it says find the sign of the trigonometric ratio. So the sign of x. So sine is opposite over hypotenuse. So the sine of x equals 15 over 17. And they gave the answer as a decimal, so you just have to divide it. Number 12, solve for x. So which trig function was this one? Okay, sine. So the sine of 52 degrees equals x over 15. X is on top, so you multiply. And you get 11.8. Oh. Alright. We good? Everybody got this? Good? Alright. William, you ready? What's up with that? Oh, come on, working. You're not working. Alright. Solve the triangle. So that means you have to find all the missing parts. And you could do it different ways. Like you could, well, certainly we're going to do Pythagorean theorem to find the missing side, or you could use a trig function to find the missing side. All right. So I started off by finding angle A. You could have started off by finding angle B. It doesn't matter. I did A. So for this, I was using, actually what I did was, yeah. So for angle A, that's going to be adjacent and hypotenuse. So that was the cosine of A equals 4 over 16.4. So A, the measure of angle A is the inverse of the cosine of 4 divided by 16.4. So the measure of angle A was 75.9 degrees, or 76 degrees. Alright? So then once I find measure A, all I have to do is subtract that from 90 to get the other one, which is 14.1. So this is the measure of angle B. And then to find the missing side, you could do Pythagorean theorem. So that would be 4 squared plus b squared equals 16.4 squared. And so when you do the work, you end up getting 15.9. Alright. So you have to square those, subtract 16 from both sides, and then take the square root. It said round to the nearest 10. It said that in directions. But, I mean, I wasn't being real picky about the rounding. So for number 15, number 14, yeah. Well, I didn't show all the work. So, I used Pythagorean theorem to find DC. So this would be, what would this be? Does anyone know what 16.4 squared is? And then you subtract 268.96. Thank you. 268.96. Then we would subtract 16 from both sides. And so that's going to be 252.96. And then you take the square root of both sides, and that's how you get 15.9. Okay? Number 15. Which trig ratios are equivalent? Oh, I still didn't do 14. Alright, so for number 14, it says find the sine of theta if the tangent of theta is 4 over 3. So, how did you guys do this one?
I drew a sine, and then I put the theta right there in front.
Okay, yeah, that's what I did. Because that would give you the 4 over 3. Because the tangent is opposite over adjacent. And so this was one of those special triangles. So you could either do the Pythagorean theorem to find the missing sides, or you could just 3, 4, 5. Yeah. So if you have legs that are 3 and 4, the hypotenuse is always going to be a 5. That's a little shortcut. But you can do a squared plus b squared equals c squared. And now you can do the sine of theta. Sine is going to be opposite over hypotenuse. Again, drawing a picture on that one is useful. Which trig ratios are equivalent to 35 over 37? This is just a thinking question. Right, this is A, because you just had to experiment. So it's either going to be something to do with A or C, either way. So, like, if you just say, okay, here's A, I'm trying to get 35 over 37. So this would be opposite, and this would be hypotenuse. So that would be the sine of A. So you just had to kind of experiment with that one. So you mark angle A, and then you say, okay, well, how could I get a 35 over 37 from angle A? If I use these two sides, that's the opposite of hypotenuse. So that's the sine. Okay, and then if I use angle C, then the cosine would give you the same thing. It would also be 35 over 37, because if you're here, then this is now the adjacent side, and that's still the hypotenuse. And this is the last one. It says a cow stands 27, so this is the cow. This is the building. So that means this is 27. And the building is 15 feet tall. What is the angle? So you're looking for an angle. So this would be opposite and adjacent. So that would be the tangent of x equals 15 over 27. So x equals the inverse tangent of 15 over 27. When you type that into the calculator, you get 29. If you just said 29, that was fine. Okay? I'm not going to do the bonus.